Okay, good day, grade 8. Welcome to our science class. We will be discussing about the electron configuration. Electron configuration is called electronic structure, the arrangement of electrons in energy levels around an atomic nucleus. To further discuss this, let us start with the fundamental, which is about the subparticles of an atom. Last time we discussed the subparticles of an atom and where they can be found in an atom. In this model of an atom, it states that a nucleus is surrounded by shells of electrons. Each shell holds a different maximum number of electrons. In the first shell, we have 2 maximum number of electrons. In the second and third shell, we have the maximum number of 8 electrons. Have you still remember the scientist having this model? Will you please type down in our comment section who is the scientist? Bigyan ko po kayo ng clue. The first letter of his surname is letter B. Okay? Alright, the answer is Niels Bohr. Okay. In 1900s, Max Planck, who is the man standing in the right side, okay po, in the right side of our picture, okay po, developed his quantum theory, which states that energy exists in fixed amounts called quanta. In 1913, Niels Bohr, who is in the left side, applied Planck's theory to electrons. He proposed that electrons could only exist in fixed energy levels. The main energy levels are called the principal energy levels, and they are given a number. And those numbers are called the principal quantum number, and we can use the symbol of small letter n, with the lowest in energy being 1. Okay, each principal energy level contains a different number of sub-levels. There are 4 sub-levels labeled in order of increasing energy. We have S, P, D, and F. Each holds a different number of electrons. Okay, let's have the sub-levels. For the S, it has a maximum number of 2 electrons. For P, it has 6 maximum number of electrons. D has a maximum number of 10 electrons, and F for the maximum number of 14 electrons. And then for the principal energy level number 1, the sub-level of it is 1s. And then for the principal energy level number 2, it has sub-levels of S and P, and we can also write number 2, to know that these sub-levels are placed under the principal energy level number 2. For energy level number 3, the sub-levels are S, P, and D. Again, we're going to write the principal energy level so that we can identify in which energy level they belong. So again, in principal energy level number 3, the sub-levels are 3S, 3P, and 3D. For the principal energy level number 4, the sub-levels are 4S, 4P, 4D, and 4F. For the principal energy level number 5, we have sub-levels of 5S, 5P, 5D, and 5F. And then for 6 and 7 is the same with this principal energy level number 4. Ang pinagkaiba nga lang, papalitan natin yung first number, Kung ang principal level ay number 7, yung sub-levels niya na SPDF, lalagyan natin ng 7 sa harap. So, ang magiging sub-levels ng principal energy level number 7 ay magiging 7S, 7P, 7D, at 7F. Now, what will be the maximum number of electrons for each principal energy level? Balik tayo sa principal energy level number 1. Ang principal energy level number 1 ay mayroong sub-level na S. At kung babalikan natin yung ating chart, sa taas, the S level has a maximum number of 2 electrons. So kung ang sub-level ng principal energy level number 1 ay S lang, ilan ang maximum number of electrons? Please type down your answer in the comment section. Okay, very good. The answer is 2. And then for principal energy level number 2 na mayroong sub-levels na S at P, at ang kanyang maximum number of electrons ay 8. Paano po nangyari yon? again, sa S sublevel, mayroong 2 maximum number of electrons. I-add natin yung P na mayroong maximum number of 6. So, 2 plus 6, meron tayong 8 maximum number of electrons under the principal energy level number 2. Then after that, sa principal energy level number 3, as you can see, the sublevels are S, P, and D. So, we're going to add the maximum numbers of each sublevels. For S level, sublevel, we have the maximum number of 2. Sa P, we have maximum number of 6. So, 2 plus 6, we have 8. And then, sa letter D, sublevel has a maximum number of 10. So, 8 plus 10, the maximum number for principal energy level number 3 ay 18. And then, for the principal energy level number 4, sabi nga nakalagay dyan, ang sublevels niya ay S, P, D, at F. And then, the maximum number ay 32. Paano po ulit nangyaring naging 32? Sa S, merong maximum number of 2. Sa P, may 6. So, 2 plus 6, we have 8. Sa letter D, we have the maximum number of 10. So, 8 plus 10, we have 18. And then, sa F, with the maximum number of 14, ano po ang sagot? 18 plus 14, we have 32. Okay? Then, for the S, P, D, and F, the different sections of the periodic table are very important in understanding the electron configuration. And there are 4 blocks in the periodic table. We have the S block, P block, D block, and F block. Let's see this block table. As you can see in the left side of the periodic table, we have this what we call the S block, except for the element helium, which is under the S block also. Okay? And then in the middle part, we have the D block, and then the P block, which is located in the right side of the periodic table, and then sa baba po, we have the F block. Okay? This shows the different blocks in the periodic table, and it also shows in what order to write electron configuration. Sunod-sunod po iyan. So, let's have this one. 1s. Okay? So, wala namang 1s, 1s, diba? Nakalagay. So, 1s and 1s is the same. Okay po. So, 1s, and then after 1s, 2s. Put tayo sa second row, 2s. And then after that, 2p. After 2p, baba tayo sa third row. We have 3s. And then, 3p. After the third row, let's go to the fourth row, 4s. Then after the 4s, we have 3d. Then 4p. After 4p, baba tayo sa fifth row, we have 5s, 4d, 5p. After 5p, baba tayo sa sixth row, we have 6s. Pero mapapansin po ninyo, no, mayroong arrow pababa. Kasi itong mga elements na nasa baba under the F block ay karugtong po nung numbers, no? After the 6s. So, we have, after 6s, we have 4s. And then, balik tayo sa taas, 5d, and then 6p. After 6p, baba tayo sa 7th row, 7s. And then, may makikita na naman kayong arrow pababa. Again, karugtong po ulit yan siya. So, after 7s, we have 5f. And then, after 5f, balik sa taas, 6d. And then, meron pa po tayo dito mga elements under the P block, no? Specifically, the 7p. So, after 6d, we're going to 7p. And that's how the electron configurations flow in this block table po. Now, let us see if you understand the block table. You're going to type your answer in the comment section. I'm going to give it 10 seconds to answer each. Let's start with arsenic. Arsenic with a symbol of AS. Okay, what will be the block table or block table of arsenic? Please type down your answer. 10 seconds starts now. Okay, so the answer is 4p. Bakit po 4p? 4p kasi nasa pang-apat na row. Bilangin nga natin kung tama kung pang-apat. 1, 2, 2, and then 3. Okay, nasa pang-apat si arsenic. Bakit po letter P? Kasi, again, ang P blocks natin ay nakalocate po sa right side ng ating periodic table. So, kaya po siya P, 4P. Okay, check. Next, calcium. What will be the block table of calcium? Okay, the answer is 4s. Bakit po 4s? Again, nasa pang ilang row? Yung ating calcium, nasa 4th row. Okay. And then, bakit S? Kasi si calcium ay nakalocate sa S block. Kaya po, ang sagot ay 4s. Another example is lithium. Nasa pang ano pong block table si lithium? Type your answer in our comment section. Great! The answer is 2s. Bakit naman po naging 2s? Kasi po, nasa pangilang row si lithium? Nasa pangalawa. Bilangin nga po ulit natin, 1 and 2. Bakit po s? Kasi po, sabi natin kanina, ang S block po ay nakalocate sa left side ng ating periodic table. So, the answer is 2s. Okay, good job. Relate. Now, let's move with the abba principle. The word abba came from the German word means construction. As part of Niels Bohr's work on electron configuration, he developed the abba principle, which states how electrons occupy the sublevels. The abba principle states that the lowest energy sublevels are occupied first. Sila muna yung mauunang ma-occupy. Okay, yung mga nasa pinakababa po muna. This means the 1s sublevel is filled first, followed by 2s, 2p, 3s, 3p, and so on. However, in our chart here, the 4s sublevel is lower in energy than the 3d. So, this will fill first. Okay po, sa pagkakasunod-sunod po kasi, alin po muna ang mauuna? Yung 3d o yung 4s? So, ang mauuna po, based on the energy, is yung 4s. Kaya siya po muna yung mauunang malagyan ng electron bago yung 3d. And as you remember po, no, sa sublevel, mas mauuna si S bago si letter D. Okay? Next, let us have the shortcut for writing the electron configuration o yung guide para mas mabilis nating maalala yung pagsusulat ng electron configuration. So, we are going to use the chemistry. It will help you to remember the arrangement of the energy sublevels. So, let us put first the S level. Kasi siya yung nasa unang-unang sublevel, di po ba? So, we are going to start with number 1, of course, kasi yun yung pinakamababa, 1. We are going to put that in the star. Okay? And then, anong sunod ng 1s? Siyempre, 2s. Saan ilalagay ang S? Kung maaalala po ninyo, di ba, sabi ko kanina, yung S block ay nakalocate po sa left side ng periodic table. So, we're going to put all the S levels at the left side of this chemistry. Okay, so we're going to put 2S, then 3S, pababa na po, 4S, 5S, 6S, and 7S. Okay, ano po yung second na sublevel? The second sublevel is letter P. Okay, so dahil siya ay second level, we're going to start at number 2. Tandaan, ang P block po ay nasa right side. So, lahat ng circles natin dito sa chemistry, lalagyan natin ng P. Pero, mag-i-start tayo, sabi ko nga, sa number 2. So, let's start with number 2P. And then, pababa, 3P, 4P, 5P, 6P, and 7P. Next, ano yung pangatlong sublevel? We have letter D, sublevel. Dahil siya ay pangatlo, we're going to start at 3D. Ngayon, saan siya ilalagay? The 3D or the D blocks are written in the middle of S and P. Di po ba? Naalala nyo po sa periodic table kanina. Now, we're not going to put 3D between 3S and 3P. Bakit? Kasi po, D sublevel is higher compared with P sublevel. Nasa iisang level lang sila. So, ibig sabihin, kung ilalagay mo si 3D sa pagitan nilang dalawa, para ka na bumalik sa simula. Diba? So, hindi siya magiging continuous. So, ang gagawin natin, ibababa natin sa pagkakasulat si 3D sa pagitan ng 4S at ng 4P. So, let us write 3D. Ayan, 3D pababa, 4D, 5D, and 6D. Now, ano yung pang-apat na sublevel? We have the F sublevel. Dahil siya ay pang-apat, we're going to start at number 4, no? 4F. Dahil si F ay mas mataas, no, kay P sublevel, we are going to put 4F sa level ng 6S, 5D at ng 6P. Okay? So, let us write 4F. And then, pababa, 5F. Okay? So, nakumpleto na natin yung mga sublevels. Ngayon, paano natin pagkusunod-sunurin using this chemistry? Again, let's start with the star. We have 1S, then 2S. After 2S, go to the right, 2P. After 2P, go back to the left, 3S. After 3S, go to the right, 3P. After 3P, go to the left side, we have 4S. And then after to the left side, after from the left side, going to the right side. So 4S, 3D, and then 4P. After nating mapuntahan si 4P, go back to the left side, we have 5S. 5S, going to the right side ulit, 4D, and then 5P. After 5P, go back to the left side again, we have 6S. After 6S, go to the right, 4F, 5D, and 6P. After 6P, go back to the left side ulit. We have 7S, going to the right side, 5F, 6D, and 7P. And that's all how we write the electron configuration using this chemistry. This will be your guide, no? Kung ano yung pagkakasunod-sunod nitong mga sublevels na to. Okay? Let us have an example here. We have AS, or the element arsenic. Its electron configuration is written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p3. Okay? In our periodic table, as you can see po, the arsenic is written in this area. Okay? Ulit po, ano yung kanyang configuration? 1s2, dalawa kasi yung 1s natin eh, di ba? Kaya 1s plus 1s, we have 1s2. Kasi nasa first row. Pagdating sa second row, we have 2s2. Bakit 2s2? Ilan ang element? Dito po, ilan na elements? We have 1 and 2. Kaya po, sa S block na to, we have 2. Second level, 2. Kaya po 2s2. Then, under the second row pa rin po tayo, pero nasa P block na po tayo, we have 2p. Ngayon, bakit naging 6? Kasi ilan ng elements? Bilangin natin. 1, 2, 3, 4, 5, and 6. So, we have 2p6. After 2p6, go back to the left side po ulit. Under third row na po tayo. Again, ano pong ulit itong block na to? This is what we call the S block. So, sa S block, under 3, energy level, we have 3s. Ilan ulit ng element? Dalawa. So, 1 and 2. Kaya po, 3s2. After that, go tayo sa P block. Ayan, sa right side. Ilan ulit ang element? So, 1, 2, 3, 4, 5, and 6. Kaya po, after ng 3s2, meron tayong 3p6. After ng 3p6, go back to the left side ulit, under fourth row. S block pa rin. Okay, ilan ang element? 1 and 2. Kaya po, 4s2. Ngayon, meron po tayong D block na kasunod. Sa D block, ilan ang elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, meron tayong 10 elements sa D, 3D10. Bakit? Kasi mag-i-start tayo sa number 3 energy level. Okay? 3 kasi magma-minus 1 po tayo pagdating po sa D. Okay? So, 3. 3D10. After 3D10 po, we have sa pang-apat na sa pang-apat na P block. So, we have 1, 2, 3. So, we have 4, P3. Sa pangatlong P, 4th P si arsenic. Kaya po 4, P3 yung dulo niya. Okay? Next, the first number is which row it's in. So, ito pong mga electron configuration natin ay meron pong mga ibig sabihin. So, para malaman natin kung nasaan yung element na to, titignan po natin yung pinakahuling sublevel doon sa electron configuration niya. So, ang last electron configuration ng arsenic ay 4p3. Again, the first number is which row it's in. Sabi ulit, yung nakasulat na unang number po ay kung saang row nakalagay yung element na yon. So, sa kanyang electron configuration, we have 4p3. So, automatic, sa arsenic ay nakalagay sa 4th row. Okay? Or 4th quantum number energy level. Check nga natin. Ayan. bilangan natin kung nasa 4th row nga si arsenic. So, 1, 2, 3, and ayun, nasa pang-apat na row nga si arsenic. And then, the character o yung letter na nakalagay, it is the block it's in, kung saan nakalagay na block yung element, which is referring to the sublevel. Check nga natin kung nasa P block si arsenic. Okay, si arsenic po ay nasa P block. Okay, so tama po, no? Yung ating pagkakasulat ng electron configuration. Then, the superscript is the total number of electrons in the sublevel. Pag sinabing superscript, ito yung mga numbers na nakalagay sa taas ng mga characters. Okay? So, we have 2, 2, 6, 2, 6, 2, 10, and 3. Ang atomic number ng arsenic ay 33. Atomic number is equal to the number of proton. Diba po? So, kung ang atomic number ng arsenic ay 33, so ang kanyang proton number is 33 din. Tandaan din po natin, in neutral atom, the number of proton is equal to the number of electrons. So, kung merong 33 number of protons, meron din siyang 33 number of electrons. Okay? So, kung bibilangin natin, yung mga superscript sa taas, ito total natin, dapat ang lalabas dyan ay 33 electrons. Kasi ang atomic number ni arsenic ay 33. So, bilangin po natin, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, we have 12, 12 plus 6, 18, 18 plus 2, 20, 20 plus 10, 30, and last, electron 3, 30 plus 3, we have 33. Okay, so, ibig sabihin po, tama yung pagkakasulat ng electron configuration natin. Okay? Now that we learn about the arrangement of the sublevels, let us now identify the number of orbitals and number of electrons for each orbitals. Okay. So, each energy sublevel has one or more orbitals. Tandaan po again, in each energy sublevel, it has one or more orbitals, each which can contain a maximum number of 2 electrons. Ulit po, sa bawat sublevel, mayroong isa o mahigit pang number of orbitals. At yung bawat orbitals na yun, meron lamang maximum number of 2 electrons. Okay. So, sa sublevel, ilan ang kanyang orbits? Meron siyang isa. Sa sublevel P, meron siyang 3 number of orbits. Under D sublevel, meron siyang 5 number of orbits. And then sa F, it has 7 number of orbits. Now, again, sabi nga sa description kanina, sa isang orbit, meron siyang maximum number of 2. Kung sa sublevel ay merong isang number of orbit, ilan ang kanyang maximum number of electrons? Type down your answer in the comment section. Very good. The answer is 2 electrons. Now, punta tayo sa sublevel letter P. Sa sublevel letter P, mayroong 3 orbits. Again, sa bawat isang orbit, mayroong maximum number of 2 electrons. So, kung meron siyang orbit na 3, at yung bawat orbit na yun may tigda-2 electrons, ilan lahat ng maximum number of electrons? Okay, mayroong 6. Kaya sa P sublevel, meron siyang maximum number of 6 electrons. And then, sa D sublevel, na mayroong 5 orbits, at sa bawat orbits, ulit ay mayroong 2 electrons bawat isa. So, 5 times 2, we have 10 maximum number of electrons. And then, for the sublevel letter F, na mayroong 7 number of orbits, again, sa bawat orbits, may tigda-2 electrons. So, 7 times 2, we have 14 maximum number of electrons for F sublevel. Okay? Now, next is the Poli exclusion principle and spin. Okay, this was proposed by Wolfgang Ernest Poli. He is an Austrian theoretical physicist. No? According to his principle, it states that each orbital may contain no more than 2 electrons. Nabanggit na kanina, di ba? Na sa isang orbit, ang maximum number niya ay 2 lang. Okay, hindi pwedeng lumagpas doon. This also introduces a property of electrons called spin, which has 2 states. We have up and down. Kaya po dalawa lang eh. Isang up at isang down. These spins of electrons in the same orbital must be opposite. So sa isang orbital, dapat merong opposite na electrons, isang pataas at isang pababa. Kaya po, ulit, sa isang orbital, ang maximum number of electron na meron lang doon ay dalawa. Isang pataas at isang pababa. Kasi nga yung principle ng spin na tinutukoy ni Poli. Okay? And then, a spin diagram shows how the orbitals are filled. Orbitals are represented by squares and electrons by arrows pointing up and down. Okay, that's an example of spin diagram for the magnesium. Magnesium has electron configuration of 1s2, 2s2, 2p6, 3s2. So, sabi kanina, dapat po, kapag nagpi-fill tayo ng electrons, we're going to start at the lowest set sub-energy level. So, ang lowest ay 1s. Under s, meron siyang dalawang electron. Isang pataas at isang pababa. Okay, so na-fill na natin yung first orbital under first energy level. Let's go up, no? Sa second energy level na merong dalawang number of orbits. We have S and P. Dalawang sub-level. We have S and P. Under S, may isang orbital na merong dalawang electron which are in opposite direction, isang pataas at isang pababa. Under P orbital, we have under P sub-level we have 3 orbitals. And each orbitals, as you can see, lahat sila ay puno. Di po ba? Kung bibilangin natin yan, we have 6 electrons. Okay? Then for 3s, sa S sub-level, may isang orbital. Okay? At sa isang orbital na yon, meron siyang dalawang electron. Now, bakit wala pong laman yung 3p? Tanong, doon sa ating bang spin diagram, merong 3p? Di ba po? Wala. So, hindi po natin lalagyan yung sub-level na 3p. Hanggang 3s lang po tayo. Okay? Now, meron po tayong rule sa pag-fill ng Again, there is a rule in filling the electrons, meaning we need to fill the arrow up in each orbital before filling down. Okay po, dito po sa rules na to, or sa rule na to, when 2 electrons occupy a p sublevel, they could either completely fill the same p orbital or half fill the p orbitals. So sa example natin dito, alin kaya ang tama dyan? Okay, tingnan nyo po yung 2p, parehas 2p2 eh. Diba? Dalawang electrons meron. Pero magkaiba ng way ng pagsulat. Alin kaya ang tama dyan? Tingnan natin. Okay, mali po yung nasa unahan at tama po yung nasa pangalawa. Hindi po pwede based sa principle or sa rule na to na sa isang orbit ay magdadalawa ng electron hanggat hindi napupuno yung ibang orbit. Anong rule yon? It is Hans rule. Again, in Hans rule, it states that single electrons occupy all the empty orbitals within a sublevel before they start to form pairs in orbitals. Ulit, sabi sa Hans rule, kailangan yung mga orbitals ay mapuno muna, depende sa number of electrons. Okay? Bago natin i-pair doon sa unang orbital. Okay? Example natin. We have phosphorus with 15 electrons and 16 electrons. Sa phosphorus, kung mapapansin natin, saka sa sulfur, ang pinagkaiba lang nila ay yung pagdating sa level ng 3p. Na kung saan, sa phosphorus, meron lamang siyang 3p3 or under sub-level 3p, meron siyang 3 electrons, samantalang sa sulfur, meron siyang 4 electrons. Kung mapapansin nyo, hindi muna pinair yung mga electrons sa unang orbital. Kasi sabi nga ni Hans rule, we need to fill up all the orbitals first bago natin i-fill as pair yung unang orbital. Okay? At kung mapapansin nyo po sa sulfur, nag-pair na po doon sa first orbital. Bakit? Kasi 4 yung kanyang electron under 3p sublevel. Eh di pa nga po, sa p sublevel, 3 lang yung kanyang orbital number. So, hindi ka pwedeng maglagay ng isa pang square dito para mailagay yung isang electron. So, para maging stable, itong 3p under sulfur, yung isang excess na electron ay babalik to sa first orbital to pair the first orbital under 3p sublevel. Okay? Next, Ngayon, sa pagsulat ng electron configuration, kung mapapansin nyo, di ba, napakahaba. In writing a very long electron configuration, we need to study the noble gas configuration, or what we call the core symbol. Okay? It is an obvious solution and convenient shortcut writing. Paano po ito? Let's talk about first the noble gas. Ano ba itong mga noble gas? Saan ba sila nakalocate? Noble gases are helium, neon, argon, krypton, xenon, radon, and ignition. They are located in the rightmost part of the periodic table, as you can see in your screen. Notice that each noble gas finishes a row or energy level. Kaya nga sila tinawag na stable gases din in other term. Kasi yung last row o yung last energy level ay paired. Okay? Lahat ng orbitals doon ay paired ng electrons. Noble gas configurations take advantage of this by condensing what you have to written. So, ibig sabihin po, sa tulong ng noble gas configuration, napapaikli yung pagsusulat ng electron configuration. Halimbawa, helium. Helium is a noble gas, tama? And helium has a configuration of 1s2. Again, sa first energy level, meron siyang isang orbital. Okay? At yung orbital na yon, again, has a maximum number of 2. Kung mapapansin nyo po, dyan sa helium 1s2, dun pa lang, makikita na natin na stable na yung configuration niya. Okay? And then, we have an example here, carbon. Carbon has a configuration of 1s2, 2s2, 2p6. Anong napansin po ninyo? Yung 1s2 ng carbon at yung 1s2 ng helium ay parehas. Okay? So, instead of writing 1s2 doon sa carbon, papalitan natin yung 1s2 ng helium. So, ang magiging noble gas configuration for carbon will be helium 2s2, 2p2. Okay? Look here in the periodic table. Helium isn't in the noble gas, and here it is. Okay? Then, C or carbon is here. Tandaan po, all the elements from lithium up to the fluorine, they can use helium as their noble gas configuration. Kasi po lahat mula lithium hanggang fluorine, lahat sila merong 1s2. So instead of writing 1s2, ipapalit natin yung core symbol na helium. And then, to be followed by the rest of the electron configuration. Okay? Let us have an example. We have aluminum here. Aluminum. What will be its core symbol or noble gas core symbol? Type your answer in our comment section. Okay, very good. The answer is neon. Okay? And all the elements from sodium up to chlorine, they can use neon as their core symbol because the last configuration for neon is similar with these elements along the third row. Okay? Balikan ulit natin si aluminum. Aluminum has electron configuration of 1s2, 2s2, 2p6, 3s2, 3p1. And again, ang kanyang core symbol will be neon. And neon has a configuration of 1s2, 2s2, 2p6, which is similar to the first configuration of aluminum. So, instead of writing 1s2, 2s2, 2p6, para mas mapaikli siya, papalitan natin yan ng neon. And then, we are going to write the preceding configuration. Diba? Mas maikli. Okay? But there is exemption to the rule, especially in D block. No? Sometimes, an electron configuration will end with 4 or 9 electrons in the D sublevel. These are unstable. Bakit? Kung babalikan natin, ilan ang orbital sa D sublevel? Type your answer in the comment section. Okay, very good. We have 5. Diba? 5. So, bakit siya hindi magiging stable? Dahil meron kang 4 electrons at meron kang 5 orbitals, meron kang isang orbital na hindi malalagyan ng electron. Diba? So, hindi siya magiging stable. Same with the 9 electrons. Kung meron kang 5 orbitals at meron kang 9 electrons. Siyempre, yung 4 na orbital may kapares. Pero yung nag-iisang orbital, walang kapares. Isang electron lang na andun. So, hindi siya magiging stable. Anong gagawin natin doon? We're going to steal 1 electron from the S sublevel before it to stabilize. Example po, yung chromium. Chromium has a configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Kung mapapansin nyo dyan, naka-highlight yung electrons ng 4s2, 3d4. Kasi yan ang gagalawin natin to make it stable. So, magiging ano mangyayari, sabi dyan kanina, we need to steal 1 electron from the sublevel before it to stabilize. So, para maging stabilize yung letter D, no, kukuha tayo ng isang electron mula doon sa katabi niyang S sublevel. So, magiging ang configuration ng chromium ay 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay? If we're going to write the noble gas configuration of this chromium kasi napakahaba, ito yung mangyayari. Okay. Again, the configuration of the chromium is this one. Diba? Yun yung original niya eh. Ito yung magiging anong magiging noble gas configuration ni chromium? Yun ay yung argon. Okay? Kasi si argon ay mayroong 1s2, 2s2, 2p6, 3s2, 3p6 na katulad ng nasa chromium. Okay? So, para mapaigay natin yan, instead na isulat yung mga naka-underline na configuration na yan, papalitan natin yan ng symbol ng argon at isusunod na natin yung mga configuration na meron kay chromium. Okay? So, again, to make it stable, we're going to get 1 electron from the S level and then we're going to put that in the D sublevel. Okay? So, to make it more stable. Kaya siya magiging argon for S1 and then 3D5.
Thank you. Don't forget to click like, subscribe, and the notification bell to be updated in the upcoming videos. See you in the next video.